Most developers look at an automated LLM leaderboard and assume they are looking at a hard measurement of capability. The ranking feels like a snapshot of objective reality. But watch what happens to those exact rankings when you swap the judge from GPT-4 to Claude 3. The entire board reorders itself. Claude family models jump by nearly 17 points. Yi rises by 23. Starling goes up by 22. The team behind Arena Hard, one of the most cited automated leaderboards in the industry, published a specific warning about this in their own paper. They explicitly noted that GPT-4's historically high scores are likely due to the GPT-4 judge favoring its own outputs, rather than demonstrating superior baseline performance. An automated leaderboard does not measure ground truth quality. It measures how closely a target model aligns with the specific internal worldview of the model scoring it. That volatility does not mean the LLM-as-Judge methodology is fraudulent. It isn't useless either. The strongest case for using models as evaluators comes from Zhang and colleagues. They validated GPT-4 against human experts on the MT-bench dataset and achieved an 85% non-tie agreement rate. That slightly edges out human-to-human agreement on the exact same setup. OpenAI ran a massive evaluation called HealthBench across 5,000 conversations. They avoided generic prompts entirely, instead evaluating the models against over 48,000 highly specific physician-written criteria. The common thread in those successes is strict boundary definition. In both instances, the automated judges were heavily grounded against a human reference process. This setup treats the judge as a calibrated proxy. A calibrated proxy is an instrument designed to tightly track an existing human benchmark. It is not an oracle capable of generating an absolute standard from scratch. To maintain that tracking, the proxy requires a narrow, bounded task family. It must be continuously maintained, and you have to validate its output locally against human raters every time the underlying rubric shifts. Relying on an LLM as an uncalibrated standard creates a false sense of security, while the measurement quietly drifts away from the ground truth it's supposed to track. When you push an LLM outside those strict bounded conditions, it loses its grounding. To compensate, the model defaults to heuristic shortcuts that we can categorize and measure. Those shortcuts form a taxonomy of specific biases that reliably corrupt automated evaluation pipelines. This table maps 5 recognized biases to their measured failure magnitudes. The first is position bias. If you simply swap the order of the answers being evaluated, consistency drops. Under default prompting, Claude v1's consistency falls to 23.8%. That is essentially random guessing. Next is verbosity bias. Researchers ran an ablation test adding the word detailed to a prompt. The model's win rate artificially spiked by 6 to 13 points, driven entirely by length, not content. Then there is self-preference. Models heavily favor outputs generated by their own architectures. Tests show judges handing out a 10 to 25 percentage point advantage to their own answers. Fourth is distractor sensitivity. If you inject irrelevant features into a prompt, models fail to separate the noise from the signal. They will flip their established pairwise preferences 35% of the time. Finally, there is rubric-induced preference drift. This is the quietest and most dangerous failure mode in the taxonomy. A rubric change can look healthy on a benchmark, while target domain harmlessness quietly drops by 27.9%. You can edit an evaluation rubric so that it successfully passes benchmark validation, but that exact same edit shifts the decision boundary underneath you, degrading the actual real-world utility of the model. The magnitude of these biases shows us exactly what is happening. Uncalibrated judges are not scoring based on functional correctness. They are scoring based on stylistic compliance and syntax. The standard engineering response to a list of identified bugs is straightforward. Write a patch for each individual bias. But that approach fails against automated evaluation pipelines because of a deeper pathology. These fixes do not compose. In a non-composable system, mitigating one specific vulnerability structurally guarantees the amplification of another failure mode elsewhere in the system. Picture trying to seal a leak in a roof, and every fix creates a new leak somewhere else. We can track this in the literature. Point-wise scoring tends to suffer from scale drift, so engineers frequently switch their architecture to pairwise scoring to gain better discrimination. But that pairwise switch inadvertently quadruples the system's vulnerability to distractor injections, pushing the failure rate to 35%. Take another common fix, refining your evaluation rubrics to force better agreement with standard, recognized benchmarks. Your benchmark indicator stays green, but the actual decision boundary drifts away from real-world helpfulness. Finally, consider self-preference bias. The obvious patch is to strip out the model identifiers and anonymize the outputs. But researchers found that anonymization merely forces the bias to migrate. The judge stops looking for stylistic cues and instead aligns with deeper, belief-level coupling. You cannot fix a broken subjective instrument by layering on more subjective algorithms. The entire structure is flawed, necessitating total process reform. The industry is currently caught in an epistemic loop. The exact same family of models is being used to define rubrics, generate outputs, and certify quality. We have seen this dynamic in older scientific fields. A decade ago, the field of psychology faced a massive replication crisis. When researchers attempted to replicate 100 top studies, the effects came in at half the size of the originals. 97% of the original studies reported significant results. Only 36% of the replications did. It proved that flexible analytics and ungrounded methodologies inherently generate false findings. Medicine confronted its own version of this problem. The response was to implement strict trial registries to strip away analytic freedom before the data was even collected. The historical solution to a broken measurement system is not a smarter statistical test. The solution is the enforcement of strict methodological hygiene. That hygiene translates into a concrete, 5-step reform package that engineering teams can implement immediately. Step 1. Version your judge. You have to freeze the specific model, the prompt, and the rubric as a single immutable instrument. If you change any of those variables, you are using a new instrument. Step 2. Build calibration subsets. Maintain small, high-quality, expert-labeled datasets to continuously validate the judge against human consensus. Step 3. Use executable checks wherever reality can verify the outcome. Did the API return a 200 status code? Did the unit test pass? Prioritize deterministic verifications over fluent text persuasion layers. Step 4. When outputs are genuinely subjective, ensemble. Rely on multi-judge aggregation and contrastive pairs to stabilize the variance. Single uncalibrated judges are purely exploratory. Step 5. Read the transcripts. Relying on quantitative evaluation numbers without qualitative human review is pure theater. Anthropic demonstrated exactly this on CoreBench. They recorded a massive 53-point swing in their model's score simply by fixing broken grading scripts and task issues with zero changes to the model's actual capability. Applying these 5 steps anchors automated processes back into observable reality, breaking the self-referential cycle that causes auto-evals to fail. The rule is simple. An LLM judge will function effectively if it is kept strictly inside a human-grounded measurement regime. But if you allow an AI to certify its own worldview without independent verification, it will silently lie to you. It is a calibrated proxy, not a source of truth. Freezing, calibrating, and auditing your evaluation instruments is the highest leverage engineering work your team can do this quarter.